Now we are going to take a brief look at MIDI control change messages, starting with the volume control. The command byte for MIDI control changes start with B. An example of a full control change message is hex B0, hex 4A, hex 1C. We label these three values as control change command and channel number, control change number, and the last one is our data value. Let's open up Atom and then take a look in BP MIDI CCs, core, source, main.c. Scroll down to the process MIDI function. And we see that we have an if statement to check for this command byte. If MIDI command equals hex B0, process received MIDI control changes, HAL UART receive interrupt, return. A control change command byte will trigger the process receive MIDI control changes function to be called. We don't need to pass any arguments because all the hex values we need are already saved in the global variables: MIDI command, MIDI note, MIDI velocity. We find process received MIDI control changes inside source MIDI control changes. For redundancy, we check to make sure MIDI command equals hex B0. If true, we will assign MIDI velocity to the local variable val and continue with the rest of the code below. The next group of code is switch MIDI note, K7, synth out amp set value, break, default, break. Switch MIDI note is a switch case operation. We are going to evaluate the value of MIDI note, which is our control change number, against each case until we find a match. For now, we only want to respond to the volume control change, which is control change 7. For simplicity in this lesson, we only have one case, and it is case 7. Directly after case 7 is a function call, synth out amp set val. Before we go to see what this function is, we should note directly after this function is a call to break, so we won't return and continue to scan for more switch case evaluations that we'll soon have more of later on. Break will end the function entirely and return us to our previous function. There's also another break after default. This default method applies if no cases match the switch value. So if we send a control change number it can't match up, it will simply stop searching at the end and return to the previous function. The function synth out amp set can be found in core, source, parameterfuncs.c. We pass on the value of val from our previous case switch function, which was MIDI velocity, and here we will process that value into a new value that the vol parameter can use, which is a global variable. And also notice that this is a float variable, so we can use decimal values with this variable. What our function here does is it's taking val and dividing it by MIDI max. MIDI max is in constants.h, and the value is 127. Thus we will have value divided by 127. So if value equals 127, we will end up with a 1. If we have a 0, we will end up with a 0. And if we have a value of 63, 63 divided by 127 equals 0.496, roughly 50% of 1. So we are converting from 0 to 127 to 0 to 1 in decimal values. But wait, we're not done yet. We do the equation twice and we multiply them together. The purpose of this is to create an exponential increase as we turn up the volume, to give the loudness better control at our lower volume and let us be more gradual as we increase the volume. If we don't do this, the lower 50% of the volume will quickly jump up in amplitude and not provide us much control. Just to prove the point, try removing times val divided by MIDI max, then recompile it and run it again, and see how the volume control reacts. You'll notice it increases the volume too quickly. When we do it like this, instead of the halfway point making volume equal 0.5, it will be around 0.25 instead. Let's take our previous example, 0.496, and round it to 0.5. Multiply 0.5 times 0.5 and we get 0.25. If we get closer to the top end of our 0 to 127 range, say 75% of it, 0.75 times 0.75 equals 0.5625, slightly more than 50%. 90% would be 0.9 times 0.9 equals 0.81. We are starting to get a closer match of actual percentage versus our exponential value. Eventually we reach the top, 100%, so 1 times 1 equals 1. Having obtained a value for vol, we can now go see where this global variable is used. Let's go to core, source, wavegen.c. We find it here in make sound just past wave compute F0. We pronounce this method as y equals y times volume. We are taking our new sample value, y, and multiplying it by the value of vol, and saving it back into y. So if vol equals 0.5, we will reduce y's value by 50%, thus decreasing its amplitude by 50%. If vol equals 0.25, then it would be lowered even more. If vol equals 1, we won't change the value at all. We will do this very simple method of altering values up or down like this very often, everywhere. This is why it's very helpful to work with sample values of -1 to 0 to +1 and have a nice 6th place decimal point value to work with in between. In the next lesson, we will start to create modulations for our synth oscillators by creating vibrato for the mod wheel to control.